So up to this point, you've learned extensively how to solve right triangle trigonometry. In order to do right triangle trigonometry, you have found various parts of the triangle. Maybe you had to find the sides, maybe you had to find the angles. If you had to find the sides, you know that given certain side lengths, you could just use the Pythagorean theorem. Right? That's used to find sides. And if you had to find angles, you relied on, let's say, finding this angle here, like angle theta, or let's actually give it a different name. Let's call it angle B because it's opposite side B, or let's call this angle A, or let's call this angle C because they're opposite those sides. You've learned to find those angles, or any other parts of the triangles for that matter. You can use the trig ratios and the mnemonic SO, CA, TOA, right? And that's allowing you to either find a missing angle or even a missing side, depending on the information given. So that's for right triangle trigonometry. But what happens when you actually don't have a right triangle? So we have non-right triangles. Well, if we bring this back to your skills from geometry, way back then, right? And you didn't have right triangles. Maybe you had an acute triangle, maybe you had an obtuse triangle. Something that you learned about in geometry was that you can still show that you have unique triangles through some congruence properties, some congruence theorems rather. And those congruence theorems, maybe what you're familiar with are things like ASA, or let's see, what else do we have? We have SAA, right? So we have these different options in which they allow you to show unique triangles, that you have unique congruent triangles. What I mean by unique is that you can only have that one triangle. If you have, let's say, an angle measure of 30 degrees, and you have a side length of 5, and then you have another angle measure of, let's say, 60 degrees, there is only one way you can form this triangle because the angle is fixed. There's no way that you can create another triangle here. So the only way the triangle can be created is if these two sides meet and you end up getting this one triangle. So the property of ASA will only give you this one triangle. Well, if that's the case, if we know that we can show a unique triangle through either ASA or SAA, remember that there are some others like SAS and also SSS. You can use these properties and be able to solve the missing parts of the triangle. Let's go ahead and go to our notes and take a look at an example where we can solve a non-right triangle. Okay, so in your notes here, I'm just looking at the next page here. Example 1, we're going to solve a triangle with the given values of A being 20 degrees, B being 80 degrees, and A also has a side length of 4. So we're going to begin by drawing the picture of the triangle. Now, if you take a look at the properties that you see here, remember that the letters are always opposite each other. So angle A will be opposite side A. So these will be opposite from each other. And one thing I always like to do is make sure that I draw a particular angle in the lower left corner, and that way just everything is consistent in my picture. Okay, so I'm going to go ahead and draw my angle A right here, and angle A is going to be 20 degrees. If that's angle A, then I know that side A with a length of 4 is therefore going to actually be on the opposite side. So I'll just make this my side A equals 4, just like that. And so you can see here that my triangle is being formed. I'm going to go ahead and call this angle B right here, and that'll be 80 degrees. And so if you take a look at the geometry property that is being held here, you can see that you have an angle, side. So what we're dealing with here in terms of a geometry congruence theorem that you're used to seeing would be an AAS congruence theorem here, right? Angle, side. Okay, and so because we have this, we only have one triangle that can be drawn here. The only way that this triangle is going to be formed is if you connect these sides together and form a triangle that way. Okay, so from here we can go ahead and now solve for the missing parts of the triangle. Okay, we've got I guess the easiest thing to do here is you can see that we have two angle measures. We have a 20 degree and an 80 degree, and you know that a triangle has a total of 100 degrees. So I'm just going to go ahead and say 80 plus 20 plus measure of angle C is equal to 180 degrees, just like that, right? 80 plus 20 give us 100. If we subtract that 100 on both sides, we can see that measure of angle C is equal to 80 degrees. Okay, so there's one of our answers. We have now found that that angle, that last angle, is 80 degrees. From here, we can just use something that we had seen in a previous video. We can use something called the law of sines. And using the law of sines, what we can do is create a proportion with all the given measures. We can say sine of angle A over side A is equal to, and then just find anything else. Let's say we want to find sine of B over side B. And what we're going to do is look for side B now. Remember that the sides with the letters are directly opposite the angles. Okay, and then we just fill in the missing values. So sine of A. One thing I want to point out here is that you always want to try, in your proportion, always try to use the values that are definitely given to you. So in this case, I guess we don't really have a choice here, but you're going to go ahead and plug in sine of 20 degrees over 4 is equal to sine of 80 degrees over B. Okay, and we're basically solving for B now. Okay, so I can just cross multiply, right? I'm going to get 4 sine 80 degrees is equal to B sine of 20 degrees, and then divide both sides by sine of 20 degrees. Okay, and then I'm going to go ahead and pull up my calculator right now. And just move this over so I remember what I said here. So I have 4, oops, it's right there, sine of 80 degrees. Remember, you want to be in degree mode. I'm going to toggle this on and off. You can see my calculator, I want to make sure I am in degree mode right there. Okay, and then I'm going to take that value, 4 sine 80 degrees, and then divide that by sine of 20 degrees. And so I'm going to get an answer, a value of B that's equal to 11.52 basically. Okay, so I'm just going to slide this over just a bit. And so now we see that B is equal to 11.52. So it's that side opposite right here is 11.52. Now the only thing left to solve for is C. So I'm going to go ahead and do that now. Remember, use what you definitely know, which is the given, which is sine A over A. What I would not recommend, so I'm going to write this down just to show you. What I would not recommend is doing sine C over C equals sine B over B. The reason why I don't recommend this is because you're technically using a value that you found, which is technically approximated, right? You're using an approximate value of 11.52 because we rounded it. So it would just make your answer for C just slightly, ever so slightly off. And so that's why I would really recommend, instead of using something that you had found, use something that is definitely given. And what's given? Well, we knew the A, and the A was already given to us. So I'm going to go ahead and make this as sine of A over A instead, just because I definitely know those are concrete values. I definitely have those values there. Okay, so I'm going to say sine of 20 degrees, that's A, over 4 again, is equal to sine of C over C. And then, oops, I should probably replace that C, shouldn't I? So sine of 20, let's see, oh no, C is 80 degrees. So sine of 80 over C, just like that. And then from there, do the same thing. You just cross multiply and divide. What I'm just realizing right now is that B and C are the same angle measures, aren't they? Which means we're going to get the same value. That C is going to give us 11.52 as well. Okay, what I just noticed right now, it was not dawning on me because I was too busy talking, monologuing here, but B and C are both 80 degrees. We have an isosceles triangle here. And so for that reason, we have to have two sides that are congruent as well. And so C, you can see, it's the same ratio, right? Same proportion. And so you get C is 11.52 as well. Okay, so make sure you box your answers. You know, you have your 3 answers there, and that'll be it. Okay, so that'll do it for this video. And in the next video, I'll show you another type of example.